States of matter. There are 3 states of matter: solids, liquids and gases. In this video, I'll teach you how to use kinetic theory to explain how particles in solids, liquids and gases are arranged and how they move. I'll also explain why and how the arrangement of the particles change during a change of state. Kinetic theory or particle theory is where we think of particles as tiny, solid, identical balls that represent the real particles in solids, liquids and gases. It's very simplified, so it's not totally correct, but thinking about the particles in this way does help us to explain the properties of the 3 states of matter and how they behave. Each time we look at the 3 states of matter, we need to consider the following properties. How much kinetic energy do the particles have? How are the particles arranged? What's the density? How strong are the forces between the particles? How do the particles move? And is the shape and volume fixed? You can change matter from one state to another by either adding heat or taking it away. All changes of state are physical changes, which means no new substances are formed. That would be a chemical change. After matter changes state, the particles end up in a different arrangement, so the properties change, which makes the behaviour change. Physical changes are always reversible, so if you reverse a physical change, the matter regains its original properties. Conservation of mass. As long as the matter is in a closed system, which means nothing can get in and nothing can get out, the number of particles remain the same, so the mass at the start is the same as the mass at the end. We call this the conservation of mass. Let's take a look at the particles in a solid. What do you notice about them? Consider the following properties. How much kinetic energy do the particles have? How are the particles arranged? What's the density? How strong are the forces between the particles? How do the particles move? And is the shape and volume fixed? The particles don't have much stored kinetic energy, so they can only vibrate about fixed positions. The particles in a solid are packed closely together in regular rows. They're always touching each other, so solids are very difficult to compress because of their high density. The forces of attraction between the particles are strong, so they have a fixed shape and a fixed volume and can't flow. I've summarised the information in the table for you. When you raise the temperature of a solid, the particles gain energy and vibrate faster, which weakens the forces between them. When the temperature reaches the melting point, the particles gain enough energy to break free from the forces of attraction or bonds that were holding them together, and the solid changes state into a liquid. We call this melting. Let's see how melting affects the properties and therefore the behaviour of the particles. Take a close look at the particles in the liquid. What do you notice about them compared to before? Consider the following properties. How much kinetic energy do the particles have? How are the particles arranged? What's the density? How strong are the forces between the particles? How do the particles move? And is the shape and volume fixed? The particles in the liquid are not in neat rows anymore, but they're still packed closely together, so they have a high density and are very difficult to compress. The particles have been heated up, so they've got more kinetic energy and can mostly overcome the forces of attraction between the other particles, so they're now able to flow. This means that they can now fit the shape of their container, but they still have a fixed volume like a solid. Again, I've summarised the information in the table for you. Have a little look. When you raise the temperature of the liquid, the particles gain energy and move faster. When the temperature reaches the boiling point, the particles gain enough energy to break free from the remaining forces of attraction that were holding the particles together, and the liquid changes state into a gas. We call this boiling. Let's see how boiling affects the properties and behaviour of the particles. Take a close look at the particles in the gas. What do you notice about them compared to before? Consider the following properties. How much kinetic energy do the particles have? How are the particles arranged? What's the density? How strong are the forces between the particles? How do the particles move? And is the shape and volume fixed? The particles in the gas have much more kinetic energy and easily overcome the forces of attraction between the particles, which are now very small. The particles move in a rapid and random way, which just means they move faster all over the place. They spread right out to fill the shape and the entire volume of their container. Because there are now large spaces between the particles, gases have very low density and so are very easy to compress. I've summarised the information in the table for you. If you cool a gas down to its condensing point, the gas becomes a liquid. This is because when you lower the temperature of a gas, the particles lose energy and can't overcome the forces of attraction to the other particles, so they move close together and condense to become a liquid. If you cool a liquid down to its freezing point, the liquid becomes a solid. This is because when you lower the temperature of the liquid, the particles lose energy and can't overcome the forces of attraction to the other particles, so they get pulled closer together and bonds form to hold them in a rigid lattice, and they freeze to become a solid. Please note that for a given substance, the melting point and freezing point are the same temperature, and the boiling point and condensing point are the same temperature as well. Under certain conditions, some solids turn straight into a gas when heated. This process is called sublimation. An example is when solid carbon dioxide, called dry ice, turns straight into carbon dioxide gas. If you're studying higher tier, you might get asked, what are the problems with the kinetic theory or particle theory? The answer is it contains inaccuracies because it simplifies the particles and the forces involved. But like I say, it does help us to visualise what's going on, especially at GCSE level, so that's why we use it. Well, I hope that video was useful and that the animations help you understand. If you want to learn more, subscribe to my channel, bang the bell all over the place, smash that like button, work hard, be nice, and bye for now.